Okay, so this is take 2 or 3 of this video. I had to redo it. Had some technical difficulty, so this is a short version. This is the last section. This is just a reminder here that proportions are fractions that are equal to each other. We solve them by cross multiplying, basically a ratio equal to another ratio or a fraction equal to another fraction. And with that in mind, we go into these two new theorems. We have a theorem called the triangle proportionality theorem, which basically says that if you have two lines that are parallel, their sides are proportional. The sides are divided proportionally. What you need to notice is how it's orientated. For example, TR over the bottom half, TQ, equals RU over US. Now you can flip it around and put this side on top of this side equals this side on top of that side. And there's other different things you can do. But basically, when you see this picture, segment on top of segment equals same segment on the other side on top of that same segment. And what this is saying is, actually, if you can prove that those segments are proportional, then you know that those two sides are parallel. So these are basically saying the same thing. One is going one way and the other one is going back the other way. And so, but they're basically saying the same thing. Now, here's an example of that. It tells us that in this diagram, QS is parallel to UT. So we know that those two lines are parallel. We know this section is 10, that's 12, this part is 6. So they want us to find this part right here. So having already done the work, here we have it right here where you can figure out that QU is 5. I said 10 over X, which I didn't know what this part was, equals 12 over 6. That's the ratio that you would set up. That's the proportion, excuse me, that you would set up. And so I reduced 12 over 6, which is something you don't have to do, but it works for me. And if it's a whole number, I keep it over 1. Cross multiply, and you find out that X equals 5. So I simply use the ratio 10 over blank equals 12 over 6, and it helped me work the problem. That's using this idea, these theorems right here. Now, another set of theorems is when you got three parallel lines cut by two different types of transversals. What happens here is that their segments are also proportional. For example, the segments of the transversal UW over WY is the same thing or equals VX over XZ. And then when you have a ray that bisects an angle right here, see those two are congruent, so it bisects that angle. The opposite side that it intersects with and the sides of the triangle are proportional. Notice that AD here over DB, that opposite side, equals CA over CB. Notice that since I started here, I have to start here, the side that are connected. The opposite side segment to the side that's connected is the proportional ratio here. So this part over this part equals this part over that part. Let's look at a couple of examples. Here's an example here where they tell me that these two triangles DEG and GEF are congruent. And so basically using the property that we just went over, I'm able to work this out. Let's look at the example here. So what we have here in this example is that I drew it, and notice I set up, let's move this out of the way, I set up X over 14 minus X. Now again, this is something that you'll have to do. I said this on an earlier video. Sometimes they don't give you what each value is, but they give you the whole side. So in order for me to figure out what this section is, I take the whole side, which is 14, and I subtract the side that I know, which is X. So 14 minus X represents this side. So notice how I set it up. I said X over 14 minus X, so this part over this part, equals 8 over 12. So I started here with X over this part, and so I start here with 8 over that part. And so that's where this came from. Now the 2/3 comes from me simplifying 8 over 12. Then you cross multiply this times that and X times 3. Doing your algebra, you find out that X equals 5.6. Again, there's no rule that says you should actually get a whole number. Here, they want us to find the length of AB right here. And since I have 3 parallel lines, remember the rule said you take this part over that part equals 27 over the blank. And that's exactly what I did over here. 24 over 32 equals 27 over x. Yes, I could have said 32 over 24 equals x over 27. That also would have worked. Again, I reduced, cross multiply, and solve, and you get AB is 36. I don't know if y'all can see that right there. It's actually showing on there. So here's 2 more theorems that says that what you can do is simply make proportions based on the relationship to sides of parallel lines and of triangles. And of course, this is probably one of the ones you'll see the most here in this example here, which basically says the sides over them each other are proportional to one another. All right, don't forget also this part here where I had to make up what the value of this was. You always take the part that's the whole minus the piece that you know. And it's tempting to say x minus 14, but that's incorrect. It's 14, the whole thing, minus the part, which is x. All right, if you got questions, let me know.